So, welcome everyone to the 2020 APEC Groundbreakers Virtual Tour by APEC OUZ. And this year, our event would be the biggest one ever done with 174 sessions. That would be including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions in 4 different languages. So please remember to register to as many sessions as you can, and all sessions would be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speakers at any time during that 2 weeks by posting questions or comments directly in the playback session page. So I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, JSON in Oracle database, features, use cases, and why developers love it, and DBAs too, by Beda Hammerschmidt. Sorry, I forgot.
Beda Hammerschmidt, that's fine.
Okay, Beda Hammerschmidt. Okay. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If any issues during the presentation, please feel free to contact me at any time on the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Beda. Take it away.
Thank you. Wonderful. Let me share my screen. Okay. I hope you can see this now. Starting my presentation now. Yes, everyone, welcome. Nice introduction. My name is Beda Hammerschmidt, and I work as a developer in the Oracle database team. I was also part of a small group that initiated the support of JSON in the standard many years ago. So we've been working on JSON for at least 6 or 7 years ago. I'm from Germany here now. It's super early in the morning, 6 o'clock. So if I fall asleep during this stuff, someone needs to yell at me because this is not a normal time when I'm awake. If you like what I'm showing you here, you can also subscribe to my Twitter handle, bch_t. Then I keep you informed about stuff that we do on JSON. I also write a blog, so that information is on here. So I will talk today a bit about JSON and JSON features in the Oracle database and in the cloud services. So first, let's take a quick look at what's JSON. So probably many of you already have worked with JSON, but there's always people that are new to it. So I give a little introduction to JSON. So it is basically a enumeration of key value pairs. It's a self-describing data structure. So on this page here, you see a JSON object that's describing a person, and it describes the person by giving a named value. So for example, we say there is a John, and John is a first name, or 25 is an age. And then we have a nested structure for the address that provides values for the address, like the street name and the city name, etc. And the object, that's the very first character that introduces the structure. It's this curly bracket. That basically consists of these key value pairs. So inside an object, a value is described by its key. And we do have another data structure here at phone numbers, which starts with a square bracket. That's the JSON array, and that is a list of values. So inside a list, it's the position that identifies a value. And this array has 2 values, and these are actually complex values, meaning that these are 2 objects. So 2 structures are nested inside this array. And similarly, address is a nested object. So this way you can arbitrarily combine these objects and arrays by nesting them, and you can build a data structure or a data representation that caters to your use case. So JSON started maybe a little over 10 years ago as a messaging format. So people needed to exchange information between a web browser and a web server, and they used JSON as the messaging format. So The next question would be, well, if this was meant to be a messaging format, why would I store JSON in a database? Because JSON was never designed to be a persistency format. And we've identified 3 main reasons that we see being either one of the reasons or a combination of reasons is why customers prefer JSON in the database. And the reason number 1 is, many of these reasons are really from the application developer's point of view. They like the fact, for example, in reason number 1, that JSON easily maps to a business object. So think of your application having to deal with mentioned person record that we saw there. And with JSON, you map each of your person objects to one JSON, whereas in a relational design, you may have to map it to multiple tables. Especially if you have repeating values like these phone numbers, you may say, well, I need a phone numbers, separate table, and then work with foreign key, primary key relationships. So one sample customer we have that's doing it for this use case is a major US insurance. We also have like a global shipping company, and they say it's just more efficient and easier to, when we have an insert, to insert one JSON record than instead of inserting or having to update multiple relational tables. The second reason is the schema flexibility. So people like that they can add new fields into JSON, whereas in a relational design, they need to add columns or need to add tables to their relational schema. So JSON gives developers a lot of schema flexibility. That's another big customer we have, a stock exchange where they have information about financial data, bonds in this case. They store them in the JSON format, and an application can choose to add more attributes as they go. And right now they have about 1,600 possible attributes, and not all of them are used for every bond, but maybe on average like 80 or 100 different attributes are being used. But the important part is that the application can decide to add a new attribute, or think of it as a flex field, without having to go to the database and change the schema. And the third reason are document or easy JSON APIs, where instead of writing SQL statements for every insert, update, or delete, or maybe even have to write these SQL statements first as a string, then put bind variables on it, and then you do an execute. Instead, you can write your SODA statements or your database statements directly in your application code. That's what I'm gonna demo a bit later. So first of all, like, how do we store JSON in the database? And the important part is that we can store it alongside your relational data. So it is basically a column type, or in a column you choose to store JSON. So it's not a separate storage just for JSON. So look at this example here. We have this well-known employee table. And let's say our use case is such that we want to provide some flex field capabilities in our employee database. So whenever we want to have a new attribute, like how many patents does this person have, or what languages does this person speak, we don't always want to go to the database and add a new column. Instead, we say we use JSON for that. So we do this by just adding an additional column. I call it flex here. And this is where the JSON goes into. So in all the versions, including 19, we would store JSON in a textual representation as a clob or blob or varchar. And then we add a check constraint on that column that makes sure that all the data we insert or update is actual JSON. And then you can see here in this insert statement, we actually insert a JSON object. It's an array of skills. So our first employees knows Java and C and C++. And our second employee, Amanda Jones, she also adds some skills, but she has an additional field called number of patents. So you see the schema flexibility aspect is also shown in this example here. And the JSON is just inserted alongside your relational values. Now in version 20, that turned out to be like a preview release, we also added a new JSON data type. So this is using a binary format, which is more friendly for queries and updates than the textual JSON representation is. But from a functional point of view, there is not that much of a difference between like a dedicated JSON type or a textual storage with a check constraint. So now if it comes to queries, we've added some capabilities to the SQL language in Oracle. We've added some operators, but first we also added the ability to look directly into your JSON by just extending your path into the JSON. So here you see in this select clause, we're selecting from our table E, the flex column, that is the column that stores the JSON. And then we can just dot our way inside the JSON. So this dot skills is extracting this nested array out of the JSON, or dot number patterns is extracting the value for the number of patterns. And with dot number function, we actually return this as a number function. So you see, it's very easy to look inside your JSON from regular SQL. I already mentioned that there is a standard. So as part of SQL 2016, we added some new JSON functions like JSON query or JSON exist. They are more powerful than the previously shown simple syntax with just dots. Here you rely on path expressions and more options to do the work. So in this example here, JSON query, for example, I give a path expression $.skills 0,1. So this navigates to the skills array. And then with a square bracket 0,1, we do select the first two values in the array and we return them as a wrapper. And you can see that from our array, which used to have 3 values, we're only selecting the first 2s. This brings us to one of the most powerful operators, which is called JSON table. So with JSON table, I can totally convert my hierarchical JSON data into the relational model. So we see our record on the left side, our person with 2 phone numbers and a nested address. And let's say we want to do some SQL analytics over it, or we want to do some relational reporting on it. So it's JSON, and let's say our tool doesn't know JSON, so we want to convert it into the relational model. And we do that by using this JSON table function or JSON table row source. And you see I'm using it in the from clause, and this is because it is generating rows. So let's quickly go over this example. So you see JSON tables first argument is jcol, that is the column that stores this JSON. And this dollar is a path expression. It doesn't mean you need to pay any money to Oracle. So JSON is a free feature. If you have an Oracle database bigger than or later than 12.102 or including 12.102, then you have all these capabilities included for free. So dollar just means select me this entire document. And then we list the columns with relative path expression. So we say, I want to have a column called first. And you see at the bottom, first is a column that's being generated, and the values we find by navigating to the associated path expression. So $.firstName means go to my first name and extract it and put it in this first column. Similarly with H, we go to the $.h path expression and we add this number to say I want the value to be returned as number. And the next one, the state, this is the varchar of length 2. And here in our path expression, we actually walk 2 steps. We first go to the address, and then we go to the state. So we are navigating to a value inside this nested object. Now it's the interesting part. We see that we have 2 phone numbers. So we do have repeating values. Our single JSON object has multiple nested structures. So we can unnest them by iterating over it. This is what this nested path does. So with $phone numbers, now look at the square bracket star. This means go to the phone numbers array and then iterate over it. Select each of the objects in the phone numbers array and extract me the value associated with $.number. These are these phone numbers here. And put them into a phone column. So you see now these 2 different phone numbers are being returned as 2 different rows. This is why we call it a row source. So we can generate more than 1 row from one input JSON. And all the other values are being repeated because they apply to the same phone number. So now imagine that you put a create view as on top of this query. Then you can query this view as if it was a regular table. So you've taken all the JSON-ness out of this this example by just using JSON tables. So it's very easy to go from JSON to relational. And the other direction is similarly easy. So if we start with a relational schema, so here I have a employee table, it's all relational and it points to the department table. So there is a join condition on department number. And basically every employee works in a department. And let's say we wanted to convert this into a JSON representation, for example, to ship it to a new Node.js based application that expects the data to be in JSON. Then I can move this JSON generation in the database by just writing my regular SQL query and putting JSON generation functions on top. So let's look how we do this. So what I want to do here is I want to return a JSON object which has the department names as key names. Let's take a look at the result at the bottom. So I want the department names as key names and the associated values. I want that to be an array of all the employees that work in this department. So how do we do this? We select from our department table and we use the JSON object ag function to build this JSON object. And then I say, well, the department name, use that as a key. So this is where we see this department name. And the value that's associated with this name, I want that to be the result of the subquery. And the subquery is the one where we go to the employee table, we do the join on the department number, and we build an array over all of the employee names, and the employee names are embedded in an object. And I could put more values in this JSON object, here, not only the name. So you see, it's very easy to also go from relational data to JSON. So this is really our converged database story. We don't want you or not only do we want you to give the ability to work with JSON, we also want to make sure that you can view your JSON data relationally, or you can convert your relational data into JSON. And we have similar capabilities for spatial data. So if you happen to have a GeoJSON data, we can convert them into the spatial object types SDO geometry and vice versa. So let's do a little demo here. It's about schema discovery and automated view creation. And for this, I have my SQL developer here. And one of the, one common task with JSON is that you want to query it, but you may not have generated the JSON, so you don't really know about the structure. So in order to demonstrate this, I've downloaded a data set from a machine learning website, and it's about wine reviews. So you can Google this and you find the data set yourself, and I've inserted into a table called stage. So if I count it, I see my one machine learning data set, and you may say, well, one row, what good is that? Well, it's a pretty big row. It's 75 megabyte of data. Now I could select it, and I see that this is JSON. It starts with a square bracket. It's a bit hard to see. So it's basically one big JSON array. And inside there's JSON, but very hard to read as a human through 75 megabyte of JSON. So I could select one value, let's say the first one, or like a random one in between. And let's copy it. And I've prepared a pretty printer here. So let's pretty print it. And you see that this one record has these fields here. So it's not many fields, but since it's JSON, I have no guarantee that this single record here is representative of all the others. Like it's schema flexible, there could be different fields in a different record. So how do I find out how my data looks like? This is what we built a aggregate function for. It's called JSON data guide. And this scans the entirety of the data and gives me a structural summary or a schema document. So this took a bit over a second to scan the 75 megabyte. Let's take a look at it. And what you see here is that the 75 megabyte got condensed to just 88 lines. And the data guide tells me, well, you have an array beta, and inside the array, there are items, and each item could have a price or a title or a value called points. And it also tells me what the data type is. So it tells me that title is a string. It would fit into a 256 character long varchar. Surprisingly, it tells me that points is also a string, but it's much shorter. So now I know how my JSON data looks like, and I could start to write queries because I know the structure. But Data Guide can do even more. It can use this information to automatically create a view. So I've written like a little PL SQL block here. The first part is just selecting the data guide that I've just shown you. This is the interesting line where I say DBMS JSON create view. So I'm creating a view called auto view on top of my stage column. And now if I describe the view, I see that each of my fields in the JSON have become columns of the view. So now I could query the view. The first thing I do is a count star. So now I know that my array has almost 130,000 entries. I can see what's my price range, and I know that price is a number, is not a number. So I put this toNumber function on it in order to find the min, the max, and the average. And I would know that my cheapest bottle of wine costs $4. The average is 35. Or I could look at what is all my different varieties, my grapes in this wine data set. So the message here is going from an unknown data set to get some level of understanding, and then being able to automatically create a view and query it took less than 4 minutes. So it's really, again, emphasizing that we want to make SQL access over JSON data as easy as possible. So what I've covered so far is the SQL side of JSON. I already mentioned a lot of the functionality is part of this open SQL JSON or SQL 2016 standard, but we did a lot of functionality beyond the standard. And one of this is the data guide and also our SODA API. So what is SODA? So when we looked at JSON, we also realized that especially application developers like JSON because of different APIs. Like MongoDB has created a good example of an API where you can use simple database operations without having to write SQL. So normally in a programming language, you may have to write SQL as strings, which then get, I don't know, assembled by string concatenation or using binds. And a lot of people find that very complex. They say, if I just want to do an insert or finding some data, I want simpler APIs. And MongoDB has created something like a document store model, or I'm not sure if they created it, but they made it popular, where instead of working with a table of custom columns of specific data types, they say, well, my mental model is our collections, which store JSON documents. So a document is typically just a JSON, and it's identified by a key. So you have a bit of key value semantics, and they live inside a collection. The collection has a name. There's typically no schema associated to a collection, so you can store arbitrary JSON inside your collection. And we realized that if someone wants that way to interact with a database, we could give them that over the relational model by creating a layer on top. And that layer is called SODA. And I will demonstrate this now. So I've prepared another demo here where I will write some Node.js code using the SODA API. And it's, again, we stay within in the world of bottles of wine. So I have a little application here written in Node.js, and it's a think about like having a restaurant and you want to store what bottles of wines you have and how much you paid for them and how many bottles you have. So we can add something here. I can pick a grape. And the purpose of this is I want to show you the code that is running this. So here, the model is that we're using JSON to represent this data set. And now let me move this to the side and show the actual code side by side. So this is my application. It's written in Node.js, and I'm absolutely Node.js expert, so it's pretty simple. But what I do here is when this Node.js application starts, you can actually see it here. It prints this wine store listening. What it basically does, it is going to my Oracle database using like the connect string, then it's getting the soda handle. Soda is this API which gives this JSON document access. And then it says collection or create me a collection which is called my wines. And this under the cover will create a table that will store these JSON documents. So now I already added a new bottle of wine. So this goes to this code path here. So I'm invoking a REST request and it goes into this branch. And what I'm doing here is I'm inserting a document. So review here, this is the document we see here. We're just inserting it. And then there's this part and get. This is what's returning us this generated key. So normally you wouldn't visualize the key that got generated. It's something internal. But here, just to demonstrate how this code works, I printed here in the response, and you see it's this is where we have this one get. But the message is like inserting your like creating the collection is one line, and an insert is also just one line. Good. So let's say, yeah, actually this one we can delete. So a delete at the bottom, that's also just a here, just a single line, go to my collection, find it based on the key and remove it. Now let's do an update. Let's say here, I want to correct the title, and let's say the wine was so good, I bought 3 bottles. So this is now an update. And this goes this code path here. We're finding the document based on the key. So the key is known because it's an update, and we replace it. So all these simple operations are a single line. Now let's query it. Let's say I want to find out all the wines which are Merlots. So I call this type, the grape type. This is a way of querying that looks very similar to MongoDB, where your query statement itself is a JSON. And let's take a look at how this works. Let me find this. Right, so we're going here. If I have this, it's called QBE. We call it query by example. It's a filter expression. If we have such a filter, I go to my collection and I find based on the filter, and then I return the associated documents. You can also do more complex queries, also very similar to MongoDB. So this is an example where you want to find out all the bottles where the quantity is greater than 2, for example. So quantity $GT means greater, and you select the corresponding rows. If you don't have any filter in our code, it is just going to the collection and returning us all the documents. Now, the interesting part is if I use such a filter expression, I put one up again, the database is not seeing this. So what this soda or this API driver does, it rewrites this to an equivalent SQL that is then executed against the table that represents this collection. So I already hinted it that SQL access is possible. So let's go to our SQL developer and describe this collection. And it was called My Wine. So there is a table called My Wines, and you see, well, it's a table, pretty regular table. It just has a very specific shape. It's storing our JSON document and a blob here in a binary representation. There is an ID associated with that I can do fast lookups, and then some additional metadata like when it was updated or created. Now, since this is in a blob, I use JSON serialize to convert it to text.
So you see that here the wine I just inserted and updated can easily be selected from SQL. I can also just do a distinct on the type. So here I'm extracting the value for type. And you see, or for example, another query is where I extract the price and the quantity and I multiply it to get like the total price for each set of wines. And this is now a relational result. Let's say I wanted to return this result as a JSON, for example, for, I don't know, reporting purposes in my Node.js app. I just put a JSON object on top and I get the very same result back as JSON documents. I could also generate new data. So let's say I want to have an array of all my names. So just the names or the titles of my wines. So I select those and I put a JSON array ag on top and you see what I get back as an array and it lists every possible name inside here. So the overall message is that with this Soda, I can have both this MongoDB style access to the data for the application developer, but at the same time, I can use SQL access over it, for example, for reporting, machine learning, analytics, etc. So how much time do we have? We're good in the time, so let's make a little change here. I always like to show that too. So let's say at some point, people ask us, do you have a wine from a specific region? And we realize we have just the name and the price quantity, but we have no region field. So let's quickly add it. So in order to have a region field, I need to update my UI to allow me to enter it. So I go to my HTML and add a entry field for my UI. I need to go to my data model. That's the JSON that's being generated and generated or updated. And I have to say, well, I also need a region field. So I'm not explaining these changes here all in detail. I've prepared them. And here in my table, I would also need a column to show them. So I've just made these changes. Let's just reload the app. You see region is here, but it is null. So let's edit this wine. You see the region is here. Let's say this is coming from Spain. And you see region got inserted. It's very schema flexible. It's here now. And I can go to my SQL. And now we should see that Spain is also in here. So this shows you one of the reasons why people choose JSON, that schema changes are really easy to do. I didn't have to go to the database and announce that there is a region field. I just stored it alongside my JSON data. Good. Yeah, this is an example. So we see a lot of our customers who considered Mongo or use Mongo really see the benefit of being able to have both a simple API as well as SQL access over the same data. And they like to see that the Soda API is very similar. So we're not going into every detail here. You just see that with MongoDB, for example, you have a very similar way. So you also work with these collections. So for example, here you're doing a collection insert. They call it insert one. We call it insert. They have also these filter concept. We do have a very similar filter concept. So it is not syntactically the same, but it is conceptually very, very similar. So if someone likes this MongoDB style of writing their application code, they can very well and very easily do that with Oracle using the Soda API. So this brings us to our overall mission, or what are we trying to achieve here? And this is, we're storing JSON in the Oracle database. On the right side, we give you all the strength of SQL for reporting or analytical operations. You get all database features like views, materialized views, transaction, PL SQL. Then at the same time, with Soda, we want to give application developers this easy to use API. And Soda is a conceptual thing. It's not limited to one programming language. I've shown you my code example in Node.js, but there is also Python and Java and REST. So you have a big choice of languages to use with Soda. So we had the big luck that end of last year, there was a Forrester, these are analysts, they evaluate different products, and they were looking at translytical data platforms. Those are databases that are used to store data transactionally, but at the same time have a significant analytical workload running on the same data. And we were clearly identified as the leader in this block. You also see other JSON databases like MongoDB here. So we were extremely lucky to be really that Forrester agreed with our vision and found that we executed very well. So the other important part is that with Oracle, you basically get an ecosystem of capabilities. And the important part is that JSON is really nicely integrated with a lot of these features, or probably most of the features. So we have indexing, you can use partitioning, there is materialized view. If you have an Exadata, we push down these operations. There is a lot of security features that you can use with JSON. There is support for spatial. So it's really, if you're an Oracle DBA, it's quite easy to extend your skills or reapply your skills over JSON data as well. So one other thing I would quickly want to show you is our new autonomous database. So this is very interesting as it allows you to actually get a cloud account. So this is what I'm showing here, and I'm using my I've used my private email here. So this is something you can do as well. You get an always free database. So you see here, you're using an always free tier account. I will not upgrade to a paid account. So this is always free. And there is a new cloud service called Autonomous JSON Database. That for now is not enabled for always free. So you can use some cloud credits that you likely get if you sign up. But it doesn't matter, that this is grayed out because you can use autonomous transaction processing in the always free account, which has the same capabilities. So you see here, I have a database in the cloud. It's always free. And let's use this to do some Soda. So what I do here is I go on the SQL Developer web and I sign in. Hopefully my password works, looks good. And this gives you a SQL console where you can try out JSON operations and especially Soda operations. So you can do Soda help and you will get a list of Soda commands. So let's quickly do a bit of Soda here. And this is actually, you can try out today, just sign up and do the same. This is a blog I wrote on this service. And that has some example that you can use. It's also giving you like some metrics that it's cheaper than MongoDB Atlas and faster. So I'm not going into the details. It's an interesting read, but there is a tutorial at the bottom and that's what we're gonna do here. So I will create a collection called cities. I'm just copying it here. And now I have a collection here. So this is the table to store JSON data. Now let's insert some JSON documents. So assume you have an application about cities. So I'm not doing SQL inserts, I'm doing these Soda inserts and look at the values. So I have some information about a city. So San Jose is a city, it has a population and it's in one county named Santa Clara. And let's assume we started our application assuming that a city belongs to one county. And later we realized that there are cities which belong to multiple counties. So in a relational design, you probably have a problem at this point because you either need to add a column or have another table for your multiple counties. And in JSON, it's easy. You just turn your value for county into an array. So let's execute these two. Okay, so this was the first one. I'm now inserting my JSON strings here. And now we can use Soda to query the data. So I'm doing a get operation here, and this is my filter expression. I'm looking for all the cities where the county is Fulton, and you see that Atlanta got selected, and the county is not equal to Fulton, but Fulton consists is contained in this array here. Another example would be, give me all the cities where the population is greater than 250,000, 250,000, and that would select both cities. And you see it's the same MongoDB style of writing your filter. And now if I describe cities, then you see that it is actually, it's actually a regular table, the same shape as I've shown before. And because it's a regular table, you can, for example, do a SQL operation over it. This is selecting from our cities collection or cities table. It is then going to our JSON document. That is what stores the JSON data. It is extracting, let's just run this, selecting the name and the population, and the population as a number. And then we're iterating over our nested county array. So county does not have to be an array, but it can be an array. And we select the county name. And now you see our two cities actually return 3 rows for Atlanta 2 because it has, it's part of 2 counties. Great. So you can try this out, sign up for the cloud and do this yourself. These are some next steps, including the links to the Soda drivers and to our development guys. And with this, I close my presentation in time. Are there any questions? If not, I just put back the slide and you can take a photo if you want, and then you have the steps and the URLs. And we're good in time, right? 2 more minutes, yes. 1 minute left or so. Yeah, perfect. I can
so
go
we still have time for questions. So if you have any question, you can type in your question in the question and answer.
Yep, I haven't watched that. And you can also always contact me afterwards if you have any questions. So my email is just beda.hammerschmidt@oracle.com. And I'm very happy to discuss your JSON requirements with you.
Yep. And of course, this presentation is going to be uploaded in the Groundbreaker site. So yeah, I guess we have one question. Beda?
Great. Chris, what's the difference, the JSON difference between ATP and AJD? Actually, there are none. So ATP, it's short for Autonomous Transaction Processing. That is the cloud service for transaction processing. That has all JSON capabilities. The difference to Autonomous JSON database is that Autonomous JSON database is significantly cheaper if you use the non-free option. And the reason why it's cheaper is that we want to attract like JSON developers, and you get the same capabilities as ATP, but only 20 GB for relational data. So you can't use the Autonomous JSON database as a pure relational database. So it's really meant for JSON workloads. But if you want to try out JSON, you can sign like I did here, just sign up for always free ATP, and you get a free database, I think, for life, which is good enough to like really do some small trials and play with it. And if you realize you can easily upgrade it to either Autonomous JSON or to full paid Autonomous Transaction Processing. Good.
Cool. Any other question? Yep. I guess we're all good, Beda. So
Thanks a lot.
thank you, everyone.
Really appreciate it. Okay.
Yep.
Goodbye.
Thank you for coming, and enjoy the conference. Don't forget to sign up for all other sessions, and yeah, have a good day.
Yes, you too. Bye.